Okay, this is Unit 7, Lesson 4. This is another special triangle. This is a 30, 60, 90 triangle. So anyway, what we learned about the 45, 45, 90 is a good one, but this one is something else that will complete a lot of your toolkits. So here's what we got. First thing we got is definitions and such. So the first place you start out with this is you draw an equilateral triangle. Okay, it doesn't really matter what size you make it, but the thing that makes it easiest to see what's going on with this is if you make each side of it to be 2. Then once you get the equilateral triangle with all sides of 2, you drop a perpendicular from an altitude from the top vertex A to the base. So it's going to look something like this. Okay, so you start out with an equilateral triangle. As we've noted before, an equilateral triangle is also equiangular. So there's 60 degrees in each one of these big angles. When you drop the altitude in an equilateral triangle, this bisects this angle up here, which cuts it into two 30-degree angles. So each one of these small triangles then is a 30, 60, 90 right triangle. Okay? That's what they're saying right here. So we're going to label the hypotenuse, which is going to be one of these, as 2x. So we're going to redraw that triangle right here, one of the two triangles. We're going to take one of these triangles, put it right here, put the 30-degree angle here, 60-degree angle here, and we're going to note that this is 2x here, the short side is x, and this is a for the altitude. Okay, so we're now going to use the Pythagorean theorem to find out what this is, because we know this is 2x and this is x. We can find what a is. Okay. So the altitude here is going to be this. It's going to start out as the Pythagorean theorem, which is x squared plus a squared equals 2x squared. We're going to solve for a. So the next thing we're going to do is we're going to go ahead and simplify this to some degree. So we're going to take the 2x squared, square it. That gives us the 4x squared. We're going to subtract the x squared from both sides. So the x squared ends up over here. So we have a squared is equal to 4x squared minus x squared, which nets out to 3x squared. Okay, at this point we're ready to solve for a, so we take the square root of a squared, which gives us a. That's equal to the square root of this, which is the square root of 3x squared. X squared is a perfect square, so that leaves us with x square root of 3 for the result. Okay, so that's the length of a right here. Okay, so we're going to use those in order to form the ratios that we need to get the information like we did with the 45-45. Okay, so the following concerning a 30, 60, 90 triangle, you need to memorize this. Like I've told you before, this is something that's going to be with us the rest of the year. So here's what we have. This is 2x, this is x, and this is x square root of 3, or as they wrote it here, square root of 3x. Okay? So you memorize this. This is something that will help you as we deal with some of these problems. Okay? So now what he's going to do is we're going to substitute 1 in for all these x's, and that's going to give us this one net result here, so that this is 1, 2, and the square root of 3. Okay, notice that what's going on here is the hypotenuse is 2 times this short side. This long side is the square root of 3 times this one. Okay? So everything revolves around this short leg. Okay? All right, you need to memorize both of these triangles. Make sure you get those done. Okay, in examples 1 and 2, they want us to use x labeling of a 30, 60, 90 triangle to find the lengths that are missing. So AC in this case is 14. So they're telling us that this is 14. Since this is next to the 30-degree angle and across from the 60-degree angle, that means this is the long leg. Okay, so we're going to draw our little triangle that we had with the ratio on it, and we're going to compare them. So the 14 goes here. That corresponds to the square root of 3x. Okay, so that leads us to this. X times the square root of 3 is equal to the length of AC, which is 14. Okay, to find what x is, we simply divide through by the square root of 3, so x is equal to 14 divided by the square root of 3. Okay, the next thing we need to do is we need to find the length of AB. We now have AC and BC. So now we need to find what this is, okay? And that's what this noted here, that this is actually BC, the 14 divided by the square root of 3. Okay, so AB is the hypotenuse, and it's 2 times, if you notice here, it's 2 times the short leg. So what we simply do is we take the short leg, which we know is 14 over the square root of 3, multiply that by 2, which is what we did right here. That gives us 28 divided by the square root of 3 is what our hypotenuse is. Okay, let's go on to example 2. So example 2, they want us to do the same thing again, but this time they're going to give us some different information. So this time we have this right triangle, 30, 60, 90 again, when this time they told us that the hypotenuse is the square root of 11. Okay, so once again we use the ratios that we talked about before. So remember, the hypotenuse is 2 times the short leg, and the long leg is the short leg times the square root of 3. So the square root of 11 corresponds to this 2x. So we have 2x is equal to the square root of 11. Divide both sides by 2 gives us x is equal to the square root of 11 over 2. So CB, which is this length right here, is going to be equal to x times the square root of 3. So we know x is the square root of 11 over 2. So we simply plug it in, multiply by the square root of 3. That gives us that this long leg up here, which is the other part that's missing, is the square root of 33 over 2. Okay, AC, which is simply x, is going to be the square root of 11 over 2. Okay, all right, the trigonometric ratios for a 30, 60, 90 triangle. Okay. Once again, we go back to our definition with the ratios in it, because that's the simplest way to do it. And it doesn't matter how big the triangle gets, this ratio will always hold true. So you don't have to worry about redoing this every time you get a different triangle. Okay, so the sine of 30 degrees, as with any angle, the sine is always going to be the opposite leg over the hypotenuse. So this is why this opposite over hypotenuse is here. In this case, the opposite leg is 1, the hypotenuse is 2. So the ratio for the sine of 30 degrees is 1/2. Okay, the cosine of 30 degrees is going to be the adjacent leg, which is this one right here, divided by the hypotenuse. So this gives us the square root of 3, which is this one, over 2. So that's our cosine. Once again, the adjacent leg to whatever angle it is, whether it's 30 degrees or something else, will always be, the definition of the cosine is always the adjacent leg divided by the hypotenuse. Okay? So the tangent of 30 degrees is the only one that we're left to find. The tangent of 30 degrees is always the opposite leg over the adjacent leg, which is the definition that's for every angle. Okay, but in this case what we have is 1 divided by the square root of 3. Okay, the trigonometric ratios for a 60-degree angle. Here's what we got. We've got the same little triangle. This time we're going to focus on the 60. Okay, so this time the sine of 60 degrees is going to be the opposite leg over the hypotenuse, just like we talked about a while ago. But this is going to give us the square root of 3, because that's opposite the 60, divided by 2, which is still the hypotenuse. The cosine, as we noted earlier, is always the adjacent leg over the hypotenuse. So once again, what we're going to do here is the adjacent leg to the 60 degrees is 1. The hypotenuse is 2. So that is 1/2. That leaves us with the tangent, which is the opposite leg divided by the adjacent leg, which is going to be the square root of 3 over 1, which is simply the square root of 3. Okay, using a trig ratio to solve for x. This is example 3. Okay, so here's what we got. We've got a 30, 60, 90 triangle. We know that because we got the 30 and the 90, so that forces us to be 60. That means that x here represents the short leg because it's across from the 30, which is the smallest angle. Okay, so what they want us to find is they want us to find the length of this leg. Okay, so since the sine of 30 degrees is the opposite leg over the hypotenuse, that's the one we're going to use for this one because that has the two parts that we're looking for one of them and we know the other one. Okay, so this gives us, from what we did before, the sine of 30 degrees is 1/2. So 1/2 is equal to x over 18, forms a proportion. To solve proportions, we simply cross multiply. So 18 times 1 gives us 18. 2 times x gives us 2x. So 2x equals 18. So x is equal to 9. So this leg right here is 9. Okay, example 4. Give us a different triangle. Once again, it's still 30, 60, 90 because we have a 60 and a 90. That means the other one has to be 30. They want us to use a trig ratio to find the hypotenuse, and they gave us this leg right here, which is adjacent to the 60. So that means we're going to use the cosine of 60 degrees. The cosine of 60 degrees in this triangle is the square root of 2 over x. Okay, so what we're going to do here is we know that the cosine of 60 is 1/2. So 1/2 is equal to the square root of 2 over x. Okay, once again, this forms a proportion with the two ratios. Cross multiply and divide gives us simply that x is equal to 2 square root of 2. Okay, example 5, they want us to use a trig ratio to solve again. This time they gave us x is this leg right here next to the 60-degree angle, and 12 is this leg right here, which is across from the 60-degree angle. So this is the long leg, this is the short leg. So what we're going to do is to use the trig ratio of the tangent because we have the opposite leg and we're looking for the adjacent leg. So the tangent has parts that we're looking for. So in this particular triangle, the tangent of 60 is 12 over x. Okay, since we know that the tangent of 60 is the square root of 3, or the square root of 3 over 1 is another way to write it, we have the square root of 3 over 1 equals 12 over x. That's our proportion. Cross multiply gives us x times the square root of 3 equals 12. So we divide both sides by the square root of 3, so x is equal to 12 divided by the square root of 3. Okay, example 6, once again, they want us to know if these are possible true values. Okay, so they told us that this leg is 5 and this is 7. So this is a 30, 60, 90 triangle, so we're going to use those ratios that we've been talking about. So here's what we got. Since we got the two legs, then we're going to look for the tangent. So the tangent of 30 degrees is the opposite leg over the adjacent. So this is 5 over 7. So we want to see if that's equal to the tangent of, or congruent to the tangent of 30 degrees, which is 1 over the square root of 3. So we simply set up this proportion and try to solve it. So the square root of 3 times 5 gives us 5 square root of 3, and 1 times 7 gives us 7. So what we have here is we'll go ahead and evaluate this out using the calculator. This time that gives us 8.6603, which is not equal to 7. So these are not possible values for a 30, 60, 90 triangle. Okay, this may be the last one. That's our conclusion. This may be the last slide. I don't know. It is. So let's go back to this so you can at least see something. Okay? All right. What you need to do is make sure you make note of any questions you've got. If you've got any kind of questions at all, you need to come to class tomorrow ready to ask them. Thank you very much. See you later. Have a great day.